Welcome to Cocos 2D Tutorials, brought to you by Bob Hewland. For more information, go to bobhewland.com/cocos2d. In this tutorial, we are going to learn about the magic of tile maps. What is a tile map? In the beginning of the 1990s, Nintendo made a game called The Legend of Zelda. The game is about a boy whose task is to rescue Princess Zelda, who is locked in the dungeon of a castle. The boy must navigate through the castle, picking up things, killing enemies, and trying to rescue Zelda from her cell. The two of them escape into a secret passage through the sewers that lead to a sanctuary. Since the game world is big, it needs a lot of screen size and a lot of memory. Nintendo had only 64 kilobytes for storing video data and a screen resolution of only 512 by 224 pixels. So, how did they solve the problem? They showed just a part of the big image and scrolled in new parts of the image when the need arose. They also made up a big graphics by reusing a number of small rectangular areas, called tiles. For instance, if you're rendering a forest, you can make trees look the same. Hence, the smart approach is to reuse one small graphic entity over and over. The same goes for ground and the other parts of the game world. This is the idea behind tile-based games. A tile map consists of several layers. In our tutorial, we will use 3 layers. A background layer, a fly layer that will only hold flies, and a bird layer that will only hold birds. A tile map consists of tiles. Each tile has a coordinate. The tile in the upper left corner has the coordinates 0, 0. The one to the right, 1, 0, and so on. In our tutorial, we will have a map which is 30 tiles wide and 20 tiles high. Each tile will be 32 by 32 pixels. And that means that our tile map is 960 pixels wide and 640 pixels high. We will need to convert screen coordinates to tile coordinates. For instance, this spider position might be 550, and we want to be able to say, yes, the spider is inside the tile 2, 2. And the method we will use for that looks as follows. It accepts a position, for instance this position, and it returns a tile coordinate. If the position's horizontal component is 110, we get the tile coordinate by taking the integer part of 110 divided by 32, which is the width of the tile. And to get y, we must be careful, because the tile coordinates are calculated from the upper left corner, while the position is calculated from the lower left corner. That means that we must flip the vertical position. We take full height, which is 20 times 32, and subtract 550, and then we divide by 32. The integer part is our vertical component of the tile coordinate. Let's move on. Since our camera is smaller than the tile map, we have a need of moving the camera across the tile map. And the tile map will be attached to the Hello World layer. Now, instead of moving the spider and the camera, we can hold the camera still and instead move the Hello World layer and the attached tile map. So, if we want to move the spider to the fly, we can move the layer like this, so it appears like the spider has moved. What is the condition when to move the layer and when not to? If the spider moves within the yellow area, we have to move the layer. But if the spider moves in the green area, we don't have to move the layer. Also, if the spider tries to move outside the tile map, we don't have to move the layer either. Here is the code for calculating the movement of the layer. Let's take one particular case to see how it works. Say, for instance, that the spider wants to move to position 100-192. Taking this max will give x 240 and y 192. Taking this minimum will not change anything. And so our actual position is 240, 192. Then we subtract it from the center, which yields the viewpoint 0 minus 32. That means that we have to move our layer 32 pixels down. So let's now go to Xcode and see how it works. We are inside Xcode, and our task is to make a simple tile-based game. A spider hunts for flies to eat, but must watch out for birds. Our plan is to use an application called Tiled and use it to create a tile map with 3 layers: background, flies, and birds. Inside Xcode, we will use the classes CC_TMX_tiled_map and CC_TMX_layer. Let's begin by looking at those 2 classes in the documentation. Let's first go to CC_TMX_tiled_map. First, we observe that CC_TMX_tiled_map inherits from a CC node. And here we see that we have a class method called TileMapWithTMX_file. Creates a TMX tiled map with a TMX file. This TMX file is the one we create with our tiled application. And the name of that file will be the input to this method. And the output will be a tile map object. There is also one method called layerNamed, which returns a layer object. Let's take a closer look. To get the layer object, we need to specify a layer name. Let's also go and look at CC_TMX_tileLayer class. And here we have a bunch of methods. but we will only use one, the one called TileGID@. GID stands for Global Identifier and returns a simple integer. And if we look at that, we see that it takes a tile coordinate as input. The method returns the TileGID at given coordinate. If it returns 0, it means that the tile is empty. And if it returns anything other than 0, then we know that there is a tile at that particular coordinate in that particular layer. Let's go back to Xcode. Look at the resources we already have. We have a sound called death.mp3. Let's play it. We have a sound called eat.mp3. Let's play it. We have an image called tiles.png, and here we see 3 tiles with a background, the fly and the bird. We also have one spider image called spider.png. Let's now go and create our tilemap file with a Java-based application called tiled.jar, which you can download for free from the internet. We are inside Tiled. Let's make a new file. File, New, choose orthogonal. Our map will be 30 tiles wide and 20 tiles high, and each tile will be 32 pixels wide and 32 pixels high. So our map will be 960 pixels wide and 640 pixels high. Click OK. We have one layer here. Let's call it background. Let's create 2 more layers by clicking twice on the Add Layer button. Call one of these layers Flies and the other one Birds. Mark the background layer, go to Tile Sets and choose New Tileset. Mark Reference Tileset Image and click Browse. Choose all files for file format and navigate to tiles.png and click Open. Make sure that both margin and spaces are 1. Set the tileset name to Tiles. Click OK. There we have our tileset. Let's take this background tile and choose the paint bucket and paint the whole layer. Go to Layers and this time choose the Flies layer. Go back to Tile Sets, choose the Fly tile, choose the Pen tool and put some flies on our Flies layer. Go back to Layers and choose the bird layer. Go back to Tileset, choose the bird tile, and put some birds in the birds layer. Go back to our layers. We can turn off and on the layers. We can turn off the flies and they disappear. We can turn off birds and they disappear as well. We can turn the flies back on and birds as well, and so on. We are done with our map. Let's save it. File, Save As, navigate to your Xcode project and save it under the name tilemap.tmx. Click Save. Now we can quit the tiled application. And inside Xcode, right-click on the resources and choose Add Files. Navigate to the place where you have saved the tilemap file and add it. Let's take a look at it. You can see that it is a simple XML file. You see that it is 30 tiles wide and 20 tiles high, and you can see that we have a background layer, a flies layer, and a birds layer. Let's go to our code and see what we've got. In the helloworld.h, we have already defined some instance variables. We have a tile map, 3 layers called BG layer, fly layer, and bird layer, and 1 sprite called spider. We also see that our layer is a CC targeted touch delegate, and that is for catching touches, as explained in another tutorial. Let's go to the implementation. In the dalloc, we are releasing our instance variable objects. We have onEnter and onExit, that is for handling touches. In the init method, we are just preloading our sound effects. And here are touch begin and touch ended methods. And the only thing we do in touch ended is that we log the touch location. We have also put some pragma marks so we get some order in the jump bar up here. You see the 2 pragma marks called touches, containing 2 methods, and start and end, containing 4 methods. So, nothing special here. Let's run it anyway. If we click at the lower left corner, we see a point. And if we click in the upper right corner, we see another point. Stop and go back. We will insert some code in our init method. And the code is as follows. First, we create a tile map and add it to our layer. Then we create the 3 layers, and then we create spider sprite and add it to the layer. Let's run this. And we see a portion of our map. There is our spider. If we click, nothing happens. What we want is that if we click here, the spider should move vertically, and if we click here, the spider should move horizontally. Let's go back. Go to Touch Ended and comment out the log. Paste some code. And what are we doing here? First, we compare the touch location with the spider's position. And based on that comparison, we move the spider horizontally or vertically. Here we are checking that the new spider position is within the child map. If it is, then the spider's position will be changed. Otherwise, it will not. The last thing we are doing is calling a move layer method. Because it might happen that when the spider moves, we have to drag the layer under our camera. These two methods, set spider position and move layer, we have not written yet, so let's do that. We will make a new pragma mark for them, call it geometry, and let's insert some code. Here we have our set spider position. Here we are setting the spider position, and here we are calling a method that we have not written yet, called tile coordinates for position, that will return the tile coordinate corresponding to a given position. We need the tile coordinate in order to call the method tileGuidAt. As you can see here, we are sending the message tileGuidAt to the fly layer. If there is some file at that particular coordinate, we will play a sound effect and remove the fly. Otherwise, we will check in the bird layer, and if there is some bird there, then we will play a sound, remove the spider, and close the touch dispatcher, effectively ending the game. Let's now write this tile coordinate for position method. Let's paste it here. And as you can see, it is very short, using simple arithmetics. And we have a last method left, the one for moving the layer. Let's paste it in. And as you can see, it also involves some simple arithmetics. Okay, look in the jump bar. You see our 3 pragmas. Let's run this. Here is our spider. It moves. Let's go over a fly. It eats the fly. Let's go over another fly. Eat that one too. Let's go up. Eat one more fly. Let's now make a mistake and try to eat the bird. And there our game ends. We can't do anything except to stop and start a new game. Thank you for watching.